So in this video, we're going to do another balancing example, although this time we're going to do a combustion reaction, so a different type of reaction with a slightly different strategy that I'm going to offer. So C7H12 reacts with oxygen in the air to produce carbon dioxide gas and water vapor. So they gave us the formula for this one, not worrying about the nomenclature of hydrocarbons. That is something you learn if you take organic chemistry. But it's reacting with oxygen in the air. So oxygen is one of the 7 diatomics, so you do need to memorize which ones are diatomic, and I'm just writing them all out right now. Yep, I got all 7. So the point is, if you have oxygen all by itself, neutral compound, oxygen in the air, it's O2, it's not just oxygen. So that's very important. If you got to get the formula correct if you're going to want to try and balance the reaction correctly. I'm not going to worry about the physical states too much. I mean, this could be a liquid or a gas. Let's just say it's a liquid, and the oxygen would be gaseous. And carbon dioxide gas and water vapor. So water vapor implies it's a gas as well. So carbon dioxide is CO2 gas, and then water vapor would be H2O gas. All right. Now, balancing. So combustion reactions can be particularly tricky for balancing. So a strategy that I've come up with that I recommend is following 4 specific steps. And if you do them in this order, it works out pretty much every single time. And it can basically make balancing combustion reactions not quite so tricky, not quite so scary. But step 1 is just to balance the carbons. So we look on this side, we see we have 7 carbons, means we're going to need to put some sort of coefficient right there. And since there's just 1 carbon, a 7 in front of CO2 makes sense for that. So that is step 1. And I'll write my steps over here. So step 1 is balance the carbons. Step 2 is going to be balance the hydrogens. So since I see we have 12 hydrogens right there, and there's 2 in H2O, that means I would want to put a 6 in front of the water, so that gives me 12 hydrogens on both sides. Step 3 is going to be balance the oxygens, and where we're going to say a fraction is okay. Now, normally, you're not supposed to ever have fractions when you balance chemical equations. It must be whole numbers. And even that rule has an exception. So if you take advanced chemistry course or like the full general chemistry curriculum, fractions actually are allowed in a very special case. But if you're just learning how to balance reactions, we say no fractions, you're not allowed to have fractions. But step 4 is going to be, if you used a fraction in step 3, we'll do something about it. So for balancing the oxygens, I'm saying for right now in this moment, if you have to use a fraction, that's okay. So what that means is you count up all the oxygens you see on the right side, and you make a wish upon a star and say, okay, what number would I put in front of the oxygen to force them to be balanced? And if it's a fraction, it's okay. So I see 7 times 2, so there's 14 oxygens for the carbon, or from the carbon dioxide, and then over here I have 6 times 1, so there's 6 from the water. 14 plus 6, I'm pretty sure, is 20 oxygens. So I have 20 oxygen atoms on the right side. I need to make sure I have 20 oxygen atoms on the left side, and 20 divided by the 2 oxygens in diatomic oxygen molecule, that gives me 10. So if I just put a 10 right here, easy peasy, so we're done. Now, like I said, step 4 says if you needed to use a fraction in step 3, then you multiply everything by 2. But we didn't need to do that just now, because we used a whole number. We used the number 10. So that's it. We're done with this one. I'm going to have a couple other examples where we show what happens if you actually have to use a fraction in step 3 and you end up invoking rule number 4 where you multiply everything by 2. But otherwise, this one's balanced and we're done.